Unity Editor Scripting. One really cool feature of Unity is the ability to customize and script your own additions to the editor. To do this, you create a folder in your Assets folder called Editor, and scripts within this folder will run in the editor. For example, here I've created a class called Unity Menu. Using the menu item function, I define a menu item under the custom submenu with the name log_hello. The next two arguments define if it is unclickable and the placement of the menu item compared to other menu items. Now, if we look at the Unity editor, at the top, there's a custom button. If I click that, it drops down to reveal my custom button, log_hello. When I click the button, it runs the associated function and prints hello to the console. There's more you can do with these menu buttons as well. For example, a button that is only active when you have a sprite selected in the editor. For that, we need a true and false version of the menu item. The true version is the unclickable one, and that checks if the condition is met. In this case, it checks if the selection in the Unity editor is a sprite. If the condition is met, it will allow you to click the button. Attributes and the property drawers. The Unity editor has more fun things you can play with. One of these is attributes. Attributes are the commands in the square brackets that tell C# how to handle the code that follows them. An example of a common built-in attribute is hide in inspector. But we want to create our own attribute here that turns a variable shown in the editor red. To do that, we'll need to use property drawers. Property drawers are basically the way we can edit the things being drawn in the editor. For our custom attribute, we wanted to make text red. First, we need to define our attribute. It also needs to inherit property attribute. Next, we create our custom property drawer of type redTextAttribute, which inherits from the property drawer. Once we've set this up, we just override the onGUI event and set the text color to red and set the other properties of the GUI element back to its default. Now, if we want to use our custom attribute, we just put brackets before the public variable like this. The text in the editor will show up in red. This is great for helping mark important variables for designers in the editor. Bit masking. Bit masking is a method of encoding your data in a single byte by representing the data as the bits in the byte. While it may sound confusing at first, it has some cool uses. In this example, I want to represent the enchantments on my sword. The sword has 8 possible enchantments which I define in an enum. I set each one to bit-shifted values, representing which bit they're held in. For example, fire is the 3rd bit from the right, so it is 1 bit shifted by 2. Now I create a sword class. A real sword class would need much more than this, but for the purposes of this example, it only has an enchantment variable, an enchant function, and a disenchant function. The enchant function takes an enchantment type, such as enchantment.poison, and sets the correct bit to 1. By using the bitwise OR operator. For the disenchant function, I take an enchantment, invert it, then using the bitwise AND operator, I essentially set that bit to 0. In use, I can quickly set and remove enchantments like this, while the data will be represented like this. Scriptable objects. Scriptable objects are a feature unique to Unity that allows you to create a sort of container for data presets. Confusing at first, but it's one of Unity's coolest features. It's easier to understand with an example. Say I'm programming a strategy game, and I want a lot of unit types. Pretty much all units are going to have some similar variables, but will need different data. So I create a scriptable object called UnitData. It uses an attribute that gives it a default file name, a name in the menu, and an order priority. I define a few of the variables that all of my units will need, such as a name, max hit points, speed, and if they're attackable. Now, when I go back into the Unity editor, I can right-click in the Assets folder and create a new unit by clicking Entities. I can then set the variables and the name of this unit. Now, instead of having different prefabs for all units, I can create these instead, to hold the necessary data for each unit type. The way I would import the data later is like this. I create a unit object which has all of the necessary variables. I then make a function, load from resources, which takes a path, reads the unit data at that path, and sets the variables from that object. And just like that, you can create a ton of different units with different speeds, max healths, without any trouble at all. One thing to keep in mind with scriptable objects, however, is in general you should only use them for variables that won't change, rather than things that might change like current hit points. All of the scriptable objects inherit their properties from the same place, and changing something on one during the runtime will change it on all.